Imagine for a moment that you are standing on a dusty road in the early 1800s. You have a message that needs to get to a city 50 miles away. At this point in human history, your options are incredibly limited. You can hand that message to a person on a horse, you can put it on a boat, or you can try to walk it there yourself. Regardless of your choice, that message is physically bound to the speed of a living creature. Information cannot travel faster than a gallop. For thousands of years, this was the absolute ceiling of human coordination. If a king died, if a war ended, or if a market crashed, the people just a few towns over might not know for days. This physical bottleneck dictated the pace of life, the size of empires, and the way we understood time itself. Before the middle of the 19th century, time was a purely local matter. If you lived in a small village, noon was simply the moment when the sun was highest in the sky, directly above you. If you traveled 20 miles to the next town, their noon would be slightly different, perhaps by a minute or so. In a world where the fastest transport was a carriage, a 1-minute difference across 20 miles was invisible. No one cared because no one was moving fast enough for it to cause a problem. But as the industrial world began to wake up, this lack of coordination became a crisis. The arrival of the steam engine and the railway meant that people and goods were suddenly moving across the landscape at terrifying speeds. When two trains are heading toward each other on a single track, being off by a few minutes isn't just a nuisance, it is a disaster. The world needed a way to talk to itself faster than a train could move. They needed a way to sync their clocks and share their warnings across vast distances in an instant. The first attempts at this didn't involve electricity at all. In the late 1700s, people in places like France built massive towers with giant mechanical arms. By moving these arms into different positions, they could signal letters and numbers to a person watching through a telescope miles away. It worked, but it was fragile. If it rained, if there was fog, or if it simply got dark, the system went silent. It was a visual language that required a clear line of sight, making it a powerful but limited tool for the elite. The real shift happened when we learned to stop looking for signals in the sky and started sending them through the ground. By the late 1830s, experimenters in the United Kingdom had already begun using electric currents to twitch needles on a dial, creating the first commercial electric telegraphs. These early systems were often used by the growing railway networks to manage their traffic. However, these systems were complex and required multiple wires to work. The true scaling of this technology required something simpler, something that could stretch across a continent without breaking the bank. This brings us to the mid-1840s and the introduction of a system that would define the era. While others were working on complex machines, a different approach emerged that used a single wire and a very clever code. In 1844, a famous line was opened between Washington and Baltimore. When the first message was tapped out, asking what God had created, it marked a point of no return. This wasn't the birth of the telegraph, but it was the moment it became a practical, scalable reality for the masses. By translating the entire human alphabet into a series of long and short pulses, the system became incredibly efficient. You didn't need a complex machine with 5 needles. You just needed a simple switch and a length of copper. Suddenly, the bottleneck was gone. Information had been severed from the physical body. A thought could travel from a mind in one city to a hand in another at the speed of light. This change triggered a massive wave of infrastructure building. Because the telegraph was so vital for safety and scheduling, the wires began to follow the railroad tracks. Everywhere the iron horse went, the copper wire followed. These two technologies grew up together, creating a nervous system for the modern world. The scaling of the telegraph required more than just wire. It required standards. Before this, every company might have its own way of doing things. But as the networks began to touch, they had to agree on how to talk. They had to agree on the code, the voltage, and most importantly, the time. To make the trains run and the messages flow, the world had to give up local solar time. We traded the natural rhythm of the sun for the artificial precision of the synchronized clock. This was the beginning of the world as a single, coordinated machine. The economics of this shift were staggering. Before the wire, a merchant in a port city might have a monopoly on information. They knew what the prices were in London or New York, and they could use that lag to their advantage. Once the telegraph arrived, those local bubbles popped. A farmer in the countryside could know the global price of wheat the same hour it was set. Markets became more efficient, but they also became more volatile. Now, a panic in one city could spread to another in minutes. The world was shrinking, and for the first time, people began to feel the weight of global events in real time. The ripple effects touched every part of human life. Journalism was transformed. Before, news was something that happened a week ago. Now, newspapers could report on events that occurred that morning. The very style of writing changed, becoming shorter and more direct, because every letter sent over the wire cost money. It changed the way wars were fought, as generals could receive orders from their capitals instantly, rather than being left to their own devices for months at a time. It centralized power in a way that had never been possible before. If you controlled the wires, you controlled the flow of reality itself. We often think of our modern world of instant messaging and the internet as a completely new invention. But the foundation for everything we do today was laid down in those first decades of the telegraph. The idea that you can be present in a place without being there physically is a telegraphic idea. The concept of a global network that ignores borders is a telegraphic idea. We are still living in the world that the clack of the telegraph key created. We have just replaced the copper wires with fiber optics and the manual tapping with digital bits. This period of the mid-19th century was a time of frantic connections. We were linking cities, then countries, and eventually continents. But as we mastered the art of moving information, we began to run into new problems. The industrial world was growing faster than the natural world could provide for. We have the coordination, we have the speed, and we have the machines, but we were still limited by the raw materials we could pull out of the earth or grow in a field. As the telegraph wires finished wrapping the globe, the next great bottleneck wasn't about how fast we could talk, but about the very substances we use to build and color our lives. In the next episode, we will move forward to 1856 to see how a failed experiment in a home laboratory unlocked the world of synthetic dyes and industrial chemistry. This breakthrough would change the stakes once again, proving that the secrets of the laboratory were just as powerful as the pulses on a wire. If you want to see how the story of technology keeps compounding,